Okay, class, today we're in lesson 8.5, Solving Special Systems. Lesson 8.5, Solving Special Systems. Solving special systems algebraically. As with equations, if you solve a system of equations with no solutions, you get a false statement. And if you solve a system with infinitely many solutions, you get a true statement.
Hey, let's take a look at some special systems of linear equations and see what things can happen. We've seen a lot of examples where we actually get a solution. Sometimes really weird things can happen. Like we can actually have no solution, or we could have infinitely many solutions. They both sound weird, but we can both see them, and let's try to detect when in fact we'll see each of those very bizarre and possibly unpleasant situations. Let's start with an example. So here's my linear system, my system of linear equations. Y equals 2x minus 3, and together with 2x minus y equals 0. Okay, I want us to look at this in a few different ways to really get a sense of what's going on here. So first of all, let's just take each of these equations and remember that they really came from lines. So let's write them in the traditional way that we write lines. Y equals mx plus b. The m is the slope, the b is the y-intercept. If I just take each and re-express it, well, the first one's already in that nice form. So slope-intercept form. This one's going to actually require a little tweaking. I'm going to have to add y to both sides. So then I have a y equals 2x. And so I'll just write down y equals 2x. And for me, that's enough. Let's actually think about it and see that, in fact, this system will have no solution.
All right, quick refresher. The way he came out with y was equal to 2x is we got to solve the equation for y. That means we want y to be on the side by itself. So it's easier in this case just to move this y to this side. So it's a negative y. So to move it, we're going to say plus y. So we're going to add going down. A negative y, when combined with a positive y, that goes to 0. So that's gone. So what's left on this side then is just 2x. Bring your equal sign down. And then what's 0 plus y? That's going to equal to y. So we get that y is equal to 2x. Or we can say 2x is equal to y. So we can rewrite this as y is equal to 2x.
Now why? Why was I able to tell that? Well, because look, I see that the slope of each of these lines, in fact, are going to be equal. So these two lines are parallel. They're parallel, and since one has a y-intercept of negative 3 and one has a y-intercept of 0, these are going to be two lines that never actually cross each other. They never intersect. So how can I find a point that's in common, right? When I'm looking for a solution to this, I want to find out where they actually touch. But these lines are parallel, and they have different intercepts, so there's no way they're going to touch. This, in fact, has no solution. And I can stop right here because I see that I have different y-intercepts and the same slope. That's one way of seeing it, but let me actually show you a completely different way. A different way is to pretend we didn't notice that. If we didn't notice that, let's try to actually solve by, say, substitution. Well, y equals y, and so I'm going to see that if I plug this value in for that y, I see 2x equals 2x minus 3. If I bring the 2x over, so I'll subtract 2x from both sides. On the left-hand side, they drop out. I'm left with just 0 equals negative 3. 0 equals negative 3. Well, that is never true. That is never true, which means that these two together are never true, which means there are no solutions. So there's a second way that we can see there's no solution. Let me actually show you a third way, which is what we talked about at the beginning, which is to actually just graph these things. If we graph these two lines, what do we see? Well, one has a y-intercept of negative 3, which is right here. And the slope is 2 over 1, so up 2 over 1. Up 2 over 1. And so there's one of the lines. Okay? And now where's the other line? Well, that actually goes through the origin, because the y-intercept is 0. And I go up 2 over 1, up 2 over 1, and so forth. And you can see pretty clearly that these lines are parallel, they never intersect. Therefore, no solution to this system. Okay? So if we have the same slope and different y-intercepts, we know there are no solutions.
Okay, now as a review and a reminder and a refresher, and to help out those who may be stuck, what we're doing in this lesson is really a combination of everything you've been learning all year so far. Systems with no solutions. Solve, all right? You got y is equal to 2x minus 3, and you got 2x minus y is equal to 0. Method 1, compare slopes and y-intercepts. All right, now in order to do that, you must make sure that the equation is in y equals mx plus b form. Y equals mx plus b form. And don't forget that second equation, we had to solve it for y by moving the y to the other side, and it became y is equal to 2x. So once again, 2 is your slope. The negative 3 is your y-intercept. Here, 2 is your slope, and the y-intercept is 0. There's nothing there. Notice that your slopes are the same. When your slopes are the same, the lines are parallel. When the slopes are the same and the y-intercepts are different, the lines will be parallel. That means that the lines will never ever meet, so therefore no solution. And once again, the lines are parallel, and therefore there is no point of intersection. This system has no solutions, so it is an inconsistent system. Method 2, we solve the system algebraically. We learned this also. And we use the substitution method. Here we have y is equal to 2x minus 3 and y is equal to 2x. Notice y equals, y equals. That means we can set both of the y's equal to each other. So one of the y's was 2x and the other y was 2x minus 3. Now we're going to try to solve for x. Notice we have variables on both sides, 2x here and 2x there. We must try to put the variables on the same side. To do that, we move the smaller x, where here they both are the same. So it doesn't matter which one we move. So it's a positive 2x here and a positive 2x there. So we're going to put a negative 2x here and a negative 2x there. 2x minus 2x is 0, so that's gone. 2x minus 2x is 0, so that's gone. So on this side you're left with 0, and on this side you're left with negative 3. 0 equals negative 3. That makes no sense. That's a false statement. So the equation is a contradiction. Therefore, no solution. So far you've seen that by comparing the slope and the y-intercept, you got no solution. By solving for the system algebraically, it made no sense. You got no solution. And the third way to do it is to graph. And by now, everyone should know how to graph. We got y is equal to 2x minus 3. Our slope is 2. And our y-intercept is 3. So the first is a negative 3. So the first thing we graph is a negative 3. So we come down here, we graph negative 3 right there. Our slope is 2. That really means 2 over 1, which really means the rise over the run. So the rise is 2. So it means you would go up 1, 2, and your run is 1 right there. Go up 1, 2, 1. 1, 2, 1. If you had to go in the other direction, it would be 1, 2, 1 that way. Of course, you make your points as you go through and you make your line. This one, y is equal to 2x. There's no y-intercept, so the y-intercept is 0. So you start at 0. You count your slope the same way. Rise is 2, 1, 2. The run is 1, 1. Rise is 2, 1, 2. The run is 1 right there. So you put your point there, and you put your point there. Now if you were going in the other direction, it would be down 1, 2 over 1. Put your point right there. Down 1, 2 over 1. Put your point right there. And you got your line. And notice these two lines are parallel and they will never ever meet. And because they won't meet, there's no solution and there's no point of intersection.